so we're Team Modough, and I'm Luna, and this is assignment 7, and I'll be presenting the first question. So to find the water saturation from the SP log, first we're going to find the SSP. You get the SP log value from the SP log, and the SP correction factor can be used or found using figure 2.3, and that value for this problem is 1.2. And next we're going to calculate the RWA using the mud resistivity and the correlation between the SSP. And doing that, we can find the RWA, and then we just plug into RG's equation to solve for the water saturation, and the final value should be around 0.1.
My name is Kevin Pham, and I will be calculating saturation of water from apparent water resistivity at 9,750 feet. So to start off, we need to get the calculated porosity at 9,750 feet. From there, we plug it into the water resistivity equation, and then from there we have to convert it to the apparent water resistivity at 10,450 feet, which we can do with ARP's equation here. From there we take that apparent water resistivity and use it in our water saturation equation, which we end up with 10.1%.
Okay, hey, my name is George, and I'm going to do problem 5 in the homework. So the problem 5 was asking us to find the RWE for the given values of the formation, and the way you would do that is it'll be R mud filtrate times 10 to the power of SSP over 61 plus whatever the rest of that is. So essentially, is everything from that is known besides SSP, and SSP could be found from SP value times correction factor, and correction factor could be found from figure 2.8. Once you plug all the values in, you'll get the right answer for RWE. And the biggest assumption made during this solution is that the formation is actually filled fully with water. And that's it.
Alright, hi, I'm Amin. So I'm going to talk about problem 11. So when you go through the problem, you'll find out that the salinity is about 20,000 parts per million. So when you look at the graph, you find out that 20,000 is pretty low. But when you look at a real graph of salinity of each fluid, it should be seawater or salt water. So, but it will still be considered as low saline fluid. So why is it important to know what kind of formation fluid we have down there? First of all, we have to know that as salinity decreases, you can find out that you will know that rock resistivity increases as well. So from this information, you can find out the conductivity of the fluid, of whatever is down there, whether it's hydrocarbon or the water itself, as well as you can also find out the fracking pressure of the formation itself.
Hi, how y'all doing? So let's get straight to the point. There are so many ways in which SP logs are really important for the oil industry. Literally, I can't stress this enough. There are so many ways in which the oil industry would thrive, and after discovering the method of finding SP logs, the oil industry was able to find so much information that is really important for the industry in order to actually implement and actually extract oil and produce more oil. And let me start. So one thing that's really important that with SP logs you can know is you can know about the lithology of the formations in a well that's drilled or logged, and if you know the formation of this specific area, then you can know the formations of other areas that are actually really essential, like other areas that are nearby to that well. So when you're drilling a development well, they call it, because the first well is an exploration well, and then when you drill a development well around it, you could probably know the lithologies from the SP logs of that well that is nearby to it. That's the first well drilled there. And this could possibly give you an insight of the lithologies of the other formations and give you basically influence the final decision in drilling that area or not. So one thing is the lithology, which is really important. And just to give you more information about it, if you have shale, you would have basically a very small deflection. And if you have clean sandstone, you will have a big deflection. So the SP log gets a response from clean formations rather than shale formations. But this information would be essential in knowing the type of lithology, which, as stated before, is really essential. Another thing that's really important is with the SP logs, you can know the permeability of an area too. So if the area is tight and permeable, okay, so this way you can know that this area, how would you know it from SP logs? It will basically have a bigger deflection when the area is tight and permeable. So there will be a higher SP log reading. So with that, with knowing more permeable areas or not in formations, so these areas could be really important in determining, for example, permeability of the hydrocarbons that could flow through that area. For example, there are so many different things that could be really important, like more permeable areas. It could mean that that if the mud invades that zone, it's going to be less mud needed. Less mud would be going in deeper areas, because it's more permeable. So more mud will be going through a smaller amount. So the invaded zone's depth or length into the formation would be really small. And also there are other things that are really important. Okay, so basically resistivity is one of the essential things. So the mud filtrate resistivity and the formation brine resistivity, they control the amount of deflection from the SP logs as well, the spontaneous potential logs. And you can know about the resistivity of those especially the formation brine, which you don't really know until you put it down into the well, and probably the effect on the mud filtrate. It's resistivity from salinity, of course. Salinity has a big say on resistivity. With more salinity, there's going to be less resistivity. So, but the most essential thing, I would think, about knowing about SP logs, that you need to know about SP logs, is that, in a matter of fact, areas which have hydrocarbons will have SP log readings that are attenuated. So this attenuated area, it means basically unnaturally thin areas. So it would be a weaker reading, but it would be unnatural, like not expected. Like usually there's a expected shape of the shale when you read the SP logs, but there would be an attenuated SP log reading. So in a matter of fact, if you strike oil, an SP log can give you a really important indication that you have struck oil with the attenuated type of actual shape, which it will actually be showing on the SP log. However, that could be deceiving though. That could be really deceiving, because this can also indicate thin beds. Thin beds are not hydrocarbons. So basically, that's why I would say SP logs would give you a strong indication, but not a final indication. You'll need to look from the other logs and make sure that they correlate with the fact that there are hydrocarbons in this area. So it's very essential, especially for exploration wells, where you will learn about formations which you didn't learn about at these depths before. And with that, you'll be able to analyze a specific field, and possibly with an exploration well, knowing from SP logs and other logs as well, you could also actually find hydrocarbons in that area, and that's really important. Thank you very much. My name is Mohammed Al Araid, petroleum engineering major.